All right, here we go with geometry. Section 5.5, notes 33, use inequalities in a triangle. The essential question is how do you find the possible side length of the third side of a triangle? All right, so here we go with the theorem 36. It says one side of a triangle is longer than the other side, then the angle opposite the longer side is bigger than the opposite side of the shorter. So in the blank, put bigger. Actually, I think the official word would be greater than. Let me change that to a more appropriate word. Oh, there's the than, so I don't even need the than. Okay, so it'll be greater than the angle opposite of the shorter side. So if I'm looking at my picture, I notice that the side length here, A to B, is 8, and then the side length from B to C is 5. What that means is that the angle directly opposite of the 8, which opposite goes across to this side right over here. I'll make that look like an arrow. That means angle C is going to be greater than the angle opposite of the 5, which opposite would be all the way over to this direction, which would be angle A. So C is greater than the measure of angle A because it opens up less. Okay? And if I slide down, theorem 37 says one angle of a triangle is larger than the other angle, then the side opposite the longer angle is longer than the side opposite of the smaller angle. So in my blank, I'm going to put the word longer than, which would be the same thing as greater than. So if I'm looking at my picture, notice I have the 50-degree angle. The side opposite here will be longer, the longest, and this one opposite would be smaller because it's across from the angle, the smaller angle. So that means from A, that would be the side BC, would be greater than the side AB or BAB, BA, whichever you like to say. I guess here we can still use the word greater than. Whichever word you like. All right. In example 1, mark the longest angle, longest side, smallest angle, smallest side, the size of the triangle. What do you notice? Okay. All right, so if I'm looking at this side appears to be the longest. And I'm going to put some letters on here. So let's say this is A, this is B, and this one's C. So that I'm going to say this is the longest side, and I believe this one is the smallest side, and then that means this one's the middle, the medium one. And then if I look at the angles, this is the longest side, that means this is the biggest angle. Okay, and if this is the smallest side, this guy is the smallest angle. And then this one would be the medium. Okay, so smart says mark the largest angle and the longest side. Okay, so here's my longest, and here I don't need the middle, so I'll erase. Where's my eraser? There we go. Let me erase the middle because that's not needed. And let's just say this one was the smallest here, with the smallest side, and this is the longest side. On number 2, it says a long-tailed boat leaves a dock and travels 250 or 2,500 feet in a cave to a cave. Goes in this direction. 500 feet to the beach, and then 600 or 6,000 feet back to the dock is shown. One of the angles in the path is a 55 and one is a 24. What is the angle measure of the path made by the cave? Okay. If I'm looking at my two angles, I realize all the angles of a triangle must add to 180. So if I'm going to take these two values, I'm first going to add them up and then subtract that. That's 101. So if I'm looking at this kind of setup here, the 24 is the smallest angle, so the beach here must be my 24 degrees. The 55 must be my dock degrees, and then the cave has to be the 101 degrees. All right, example number 3. This is list the sides of the triangle PQR in order from shortest to longest, so smallest. I'm looking at the sides. So if I'm looking for the shortest side, I'm looking for the smallest angle, which is 45. So the side directly across from it would be QR. Okay, I'm going to say it's less than. And then the second angle is 55, so its side would be PQ. And then the largest angle has to be the remaining side, which is PR. There's your answer. And on the back, it says, okay, another boat makes a trip whose path has side lengths of 1.5 miles, 2 miles, and 2.5 miles, and angles of 90, 53, and about 35. It says sketch and label the diagram with the shortest side on the bottom and the right angle at the right. All right, so the smallest angle is this 1.5. And so all right, so if I draw a line, say 1.5, it says on bottom, okay? And it says it has a 90 degrees, so I'm going to rotate this 90 degrees. It has to be on the right, is that correct? 90 degrees. Right angle, it's sketching on the bottom, and the right angle on the right. Okay, so I need, okay, let me draw my line. This one's going to be my 2. Right there. Oh, went too far. Let me erase a little piece. Whoa. Okay. I did not erase a little piece. That to a 2 again. Okay. And then my last, this will represent my 2 miles. Down here represents my 1.5 miles. This is my right angle. And so I need to now draw diagonal. Okay, I think that's pretty close. I'm going to draw from up there down to there. And that will represent, what is it? 2.5 miles. Now, do realize I looked at the 90 degrees being the largest degree measure, and I looked at the side measurements, realizing the 2.5 was the longest side. That's why I drew the 90-degree and the 2.5 across from it. And the smallest side would have to have the smallest angle. So that means up here is a 37-degree angle. And then that means over here would be a 53-degree angle being the middle length. Okay. I can grab a hold of that and get rid of that. Okay. All right, on theorem 38, the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So to fill in my information here, as AC is my farthest side, so I'm going to take AB plus BC will be greater than the third side. Or if I take AC plus, just guess one, would be AB, that will be greater than the BC. Or I could take, I don't know, AB, get the other combination. No, not AB. Apologize. Oh, so I had the original. Okay. All right, I need the other one, not AB, but I need BC here. Plus the AC will be bigger than the AB. So I have all three combinations for this theorem. So I can find the third side. Again, if I scroll down. All right, a triangle has one side of length 14. That should be 1. O-N-E, not on. 14 and another of 10 describe the possible lengths of the third side. Okay, so in doing so, I'm going to do this theorem up here at the top. I don't have a whole lot of room, but I know two of my sides. I'm going to do 14 plus 10 has to be greater than my third side, which I don't know what that is. I'm going to say that's x. So that means 14 plus 10 is 24. If I do another combination, let me draw a line, and do 14 plus x has got to be greater than the other number, which would be 10. To solve this, let's subtract the 14, and then be x has got to be greater than, what is that, -4. And then the other combination would be 10 plus x has to be greater than 14. I subtract the 10, that tells me x is greater than 4. Okay, so I have 3 answers here that I'm looking at. For number 6, it says the x's are going to be less than 24, or there we go, the x's will be greater than -4, or the x's will be greater than 4. Now, my question is now for this one right here, this is my big question mark. Can I have a side length, because x represents the third side, can I have a side length that's greater than -4? Can I have a side length that's -3, -2, -1, -4? Can I have side lengths that are negative? And the answer is no, I cannot. So this one is not needed. So I'm looking at my other 2 answers here and realizing that the x is less than 24, but the x is greater than 4. So I'm going to put this in an inequality where I have my x in the center. I know x is less than 24, but it's got to be bigger than 4, and this represents all my values I could have for my third side. All right, following this pattern for number 7, it says one side length is 23, another one is 17. So I'm going to first take the 23 plus the 17 and say it's got to be bigger than my third side, which I'm labeling that x. 23 and 17 is, I believe, 40. Right? That's 10, here one, yeah, 40. There's one measure length. Then I'm going to take, let's say, 23 plus x has got to be greater than 17. And then I have the other combination, 17 plus x has got to be greater than 23. All right, so on the first one, if I subtract 23, oh goodness, what do I come up with? X is greater than a negative, I believe that's 6. 15, 31. Good Lord, I can't even do this in my head today. All right, so let's do that. Equals to 1. Yeah, that is 6. Okay. So we have a negative 6 as an answer here on the middle one. And then when I subtract 17 from the other side, I get x is greater than, and that one will be a positive 6. So once again, this negative I cannot use. So that means my answer ranges between 40 and 6. So there's my 40. My x is in the middle. That means it's less than 40, but greater than 6 will be my answer for the possible side lengths of the third side, the range between these two numbers. Okay, so you need to answer your summary. So determine the possible lengths of the third side of a triangle. You must first, and here's your process right here at the top, use your triangle inequality theorem. Add your two sides, it's got to be greater than your third, and then switch it around where you have your next greatest number, which here was the 23, and you take your smaller number plus your x. Put it all together in your example, and you'll have your summary.